this, which is like your audio input to your like shirt. Or if you feel like like not comfortable, you can just like do it like that too.
Okay.
If it's hard, like I mean, it's a bit hard to like clip. And then what I'll need you to do is like instruct the next speaker to grab this as well, because like that's how it's feeding the live stream.
Can.
Can?
Yeah. But this one and the mic also, right?
Yeah, cause
Okay.
like hello, sorry,
Can. Yeah.
hello. Hello. Yeah, so basically this is for like local, right? And then this is for like the live stream that we're testing out anyway.
Okay.
Yeah. Do you want to test the computer?
Combase. He went.
I thought I saw him coming. You know, if you want, you can just feel free to load it on mine.
Sorry?
If you want, you can.
building an AI community in Taiwan and then want to bring it to Southeast Asia as well as north part of Asia as well. So looking forward to see what Singapore have.
Hi everyone, I'm Alex. I'm trying to figure out what is this AI thing about. I'm an audience.
Hi, I'm Jesse, and coming out of retirement, former software entrepreneur and R&D developer, and I'm looking at AI applications for the mental health space, and especially for ADHD and autism.
Hi everyone, I'm Wilkie. I'm here more as an audience, as a learner. I'm both a business owner and an investor. I own a branding company, and we are early adopters of advanced large language models about 2-3 years ago. So right now we are customizing small language models with proprietary data and domain expertise with our clients, big and small. Thank you.
Hi, I'm Zhang. I'm just here tonight.
So I think it was a policy.
Hi everyone, I'm Sian. I'm a software engineer. Previously I worked in GovTech and VMware. And now I'm working on my own startup with Vivek here. We're exploring using AI for improving developers' productivity, like how to use AI to write code and understand code better.
Hi guys, I'm Vivek. So working on the same startup, using AI to help understand large code systems for software engineering teams.
Hi, I'm Leslie. So I'm data scientist by training. I'm not doing anything now, so I just come here to see what everybody is doing.
Hi, I'm Shabir. I'm working on a startup in the supply chain logistics.
Hello everyone, I'm Ronit. I work as a growth and strategy operator from India, and I'm here this week to explore the startup ecosystem in Singapore this year.
Hello, I'm Bernie. I come here from Tokyo, and we're building a GPU pool over there, similar to AWS and Google Cloud platform, and we're joining a conference and also this event. Nice to meet you all.
Oh, I'm also Hala, same company with Bernd. So founder and CEO of Chong from Japan. So thank you very much for today's meeting.
Hi everyone, I'm Pranay. I'm an AI researcher in the Air Force. I know that doesn't sound right, but yeah, that is the case. Yes. And I'm working on human-computer interactions, like basically developing a system for human and AI to collaborate in a air traffic controller domain. So yeah, that's what we're working on.
Hi, I'm Glenn. I work with Pranay on some of the HCI tools that we're making, and I'm mainly working on speech processing.
Yes, technically I'm also with them in the Air Force, but I'm also part of Singapore Youth AI. I'm here looking for promising young, aspiring students from the AI space. So if you are, please come and look for me. Thank you.
Hi folks, I'm Will. I'm a founding partner of Maven Group. We're a go-to-market expert bringing businesses to market here in Southeast Asia.
Hi everyone, my name is Patrick. I'm a master AI student in SMU, and I come to here just to learn more about the AI application from all of you.
Hi everyone, my name is Zhang. So I work for a SaaS company. We specialize in B2C communications. So we build our AIs, but also we're looking for a partnership to those people who can build AI customer support agents to help our customers.
Hi, I'm Gokul. I'm working for a government agency, exploring the grounded AI use cases with some real ROIs.
Hello everyone, I'm Karthik. I work for the same government agency, so we are currently doing some modernization. So we are looking at maybe if there is any opportunity for AI adoption in your system. I'm here as an audience as well.
Hi everyone, my name is Max, crypto investor for more than 10 years. Also managed to got my AI data, AI prompt engineering recently. So I got nothing to do at home, so I just come out with my friend to hang around.
Okay, my name is David, co-founder of Web3 first exchange in the world, and then I'm here to learn more into AI. In the crypto space for 13 years, so AI is totally new to me. So I want to implement my AI into my Web3 exchange. Thank you.
Hi everyone, my name is Marcus. I run a B2B lead gen agency, so we help people generate more qualified leads with outbound engines via email, LinkedIn. We use a ton of AI in our processes, so I'm looking forward to learn more about how we can accelerate and improve that process.
Hi, I'm Jovan. I'm currently a student studying computer engineering, so I'll be looking for you later on.
Hi everyone, I'm Steven Zhong, I'm from AIA. So previously I was a mechanical design engineer in the local drone company. So we used the AI technology to inspect the tunnels. Later I would go to NUS for the PhD and work as a graduate tutor. So recently I just switched my career to AI. So I'm a financial planner, and I just want to socialize and learn more about the AI in Singapore. Thank you.
I'm Jeremy. I'm working as a data scientist in Nomura, which is a financial company. And in my work, I mainly work on like AI agents for finance, but various use cases within the company. I also do a lot of freelance work, especially taking part in Kaggle competitions, right? And previously, I had something to share about the researching for solving math problems in using LLMs to solve math problems. The research is to use LLMs to solve math problems, but previously I thought about presenting today, but I didn't went ahead because one of the team members could not make it. So today I'm just here to listen.
Hello everyone, my name is Juan. I'm actually a security compliance officer, but yeah, my company also make a platform for AI solutions, so here I am.
Hi, Sabrina. I work as an AI trainer with models such as ChatGPT, Gemini. Currently trying to transition to a new role. Actually, just need to learn and listen. So that's it. Thank you.
Cool. I think we would probably start soon. So maybe you'll invite Kevin to just give a brief rundown of the launch space. And if you want to present in like the next, so we do this every month. So if you want to feel free to present in the next few months, just drop me an email too.
Okay, yeah, thanks Daniel. Hi, my name is Kevin. I'm a librarian in the National Library Board. So thank you for taking your time off to come to our space on a weekday night to come listen to all this interesting stuff. So I'm just here to really basically just invite you to come and find out more about this space itself. If it's the first, actually how many of you are the first time in this space? Quite a lot of you, right? Maybe some of the students or some of the ex-students would remember coming here to study, basically. But the space you just entered, including this program, is part of new service called Launch. So Launch is basically one of the new services that NLP has launched, started up, which is to cater to businesses, small businesses, micro businesses, entrepreneurs who want to start up. We provide business resources, we provide information, advisory, help with your research if you need to. But beyond that, what might be more applicable to you guys is that this space that you're in is completely free of charge. So you can come by and use space free of charge. We have free power plugs, we have free Wi-Fi through wireless SG. So I know Daniel and Nicole from Menlo have actually started a company more or less from this space. Yeah, so that's very inspiring. I hope that you guys can also take the lead and take your businesses to the next level by using our spaces, our resources, and so on. Yeah. So without further ado, welcome to this space. I hope you have a wonderful evening learning with us today. Thank you.
Cool. Thanks, Kevin. So how today's showcase would work is that it's actually broken down into 3 sections. So the first section would be about AI tools. So we'll have like 4 speakers here. The next section would be about embodied and interactive AI systems, and the last section would be about AI in practice. So without further ado, I will pass the time now to Ike.
Thank you. Thanks, Daniel.
Right. So before I actually get into Ekura's quality, risk management, boring stuff, right? Let's do a quick experiment to see how many of us know what is this.
It's a painting for sure. Right. What's so unique about it? There's so many. ChatGPT have a new model of generating amazing pictures. Again, every model has their own way of generating pictures. What is so unique about it? It's the first ever AI-generated portrait, which was sold, auction sold. Initial price was asking us 10K, got for about 432,500. Right? Just something to take away from today. However, evolution of AI, this is, I'm sure you guys are all in AI, this is not alien to you, but it's just to set the premise right. The evolution of AI, literally about 15, 16 months in here, February 2022 to December 2023. Right? Definitely crystal clear, better looking portraits coming in there. Right? Anybody who needs explanation on all these three categories? Raise of hands. I'll take that as a no and move on. Generative AI, AI agents and agentic AI, all the buzzwords around that, isn't it? Right. So let's get to the boring space, but try to make it interesting as much as possible. AI adoption is increasing. You can see that from the blue line. AI regulations are increasing. Unfortunately, so as AI incidents are increasing. You can see some snapshot of the fake job seekers are flooding in the market. If you are aware, probably one of the oldest incidents here is the top one, which is Air Canada chatbot speaking out the low price tickets for free. Not for free, but low price, sorry. Right. If you're unaware of where to catch those incidents, there is a global directory being maintained called incidentdatabase.ai, and you can find all the, this is one of them. There are like tons of other directories being maintained about this altogether, right? So what is the real problem here? Anybody can sense a problem? Why all of a sudden we have so many incidents or so many things going wrong? Please go ahead, Mr. from Nomura. I don't remember your name, but definitely.
Yes, I think it's because like people are using a lot of like deep fakes. Then they instead of showing their own self, they use like they can actually disguise themselves as someone else.
Yep, I think you're there and thereabouts. You're there and thereabouts. All you're trying to say is that we need to stop that, and the way to stop it is put right governance in place. Right governance, compliance, assess the risk first, right? And now, in order to do that, we know that the regulations are increasing, but I always say that it's like insurance policy. If you have an insurance policy, if you have, let's say, driver has an insurance, do you drive fast or drive slow with that policy in mind? You tend to drive safely because you know at the back of the mind, anything goes wrong, I have insurance to claim. So AI governance is all about having the right insurance and right policies, right governance and safety in place. Now, the challenge AI brings to, which is a different challenge as compared to the other software development lifecycle or adoption or compliance, is that it is quite complex to check what regulation it should adhere to and how. So we have AI-related regulations. We have the frameworks between policies and principles being maintained. Then we have technical standards, ISO, IEEE, even Singapore has their own standards board. Any organization that needs to deploy a governance process is required to formally look at all these one by one, which is at the use case specific before they adopt an AI. And that is exactly what we automate. What do we do? Everything in platform, helping organizations scale AI with confidence and control. The question is, how do we do it? Confidence is when you know what risks you have with AI. Control is the requirements, how to mitigate that risk. So what do we do in the platform? We automate risk identification and requirement generation. The moment you input the use case from the left, I'll go to the platform in a quick second, but just a demonstration, you put in a use case in the platform, it segments the risk across safety, security, legal, ethics, performance, and sustainability. Once you know your risk, we put through all the regulations and standards and give you the risk profile of your use case. Right? Quick understanding on how that is done in the platform. let's say we got a use case which is a chatbot, knowledge-based chatbot. You get in the platform, it's a pre-filled one for the demo purposes from that angle. So what you do is first the platform understands what's the context of use case and what are the regions of deployment. Are you the deployer or the provider? Once that information is got in the platform will require you to assess the data context, which is input data, output data, and the training data. Once you know that, we do the first magic, which is collate all the universe of regulation requirements, standards, and give you what you should be looking at. There are thousands of it. We make it about a couple hundreds for you guys altogether. Once that is done, we help you generate the risk profile across the 6 pillars, as we call it, which is safety, security, legal, ethics, performance, and sustainability. What you get out is your comprehensive risk profile of that particular use case in this scenario, which is the knowledge-based chatbot from that angle. That's how we streamline the entire risk identification. Once you accept the risk, that these are the risks, and you know your risk, we get you to generate the requirements, and once you adhere to those requirements, you streamline your, if somebody is aware of it, which is, we call it as the residual risk, which will come at the end to see how the eventual residual risk that you should be accepting for this particular use case. All right? I'll still go a couple minutes to take any questions if there is any. Please.
How are you approaching quality evaluation of the results that you are providing the client?
So first thing is, actually very good question, I would say that. Not many people ask me about the quality or authenticity if I have to simplify that, right? If I have to go back, you see, every requirement that we are asking you to fulfill are not being claimed by us. We're citing where these requirements are coming in from. Right, and that kind of streamline the quality of the output that we are putting it all together. Please. Absolutely right. So yes, I must say quite nice and intelligent people out there, right? Right, so it also gives you the controls, and the requirements do become part of controls depending on the risk category we are assessing. So we give you the control, but we also give you something we call condition of acceptability. Example, a model should perform to this, if I have to give you, a model performance is accepted to be 8 on 10 when you're doing knowledge-based chatbot, but it has to be 10 on 10 if the model is performing on an autonomous car in that sense. So we define you for that as well. Right, still got 1 minute left. I've just been waived. Any other last question I can take? Oh, that's brilliant. That saves us about 30 seconds. So thank you very much, guys. Thank you. You've been a really great audience. Thank you. Sorry.
Cool. So while we're waiting for the next team to set up, I would encourage everyone to come in and fill in the seats that are available. There are a couple of seats available because I think there are going to be more people streaming.
Oh, you want the type C's there as well?
Test. Can you get out of it? Okay, yes. Okay, hi, good evening, everyone. My name is Isaac. I am the marketing team lead of Revel, a smart search tool. And here with me is Wesley, the head developer of Revel. And today I'm very pleased and it's my greatest honor and pleasure to be able to share with you a product that my team and I have been working on for the past year. Okay, so just to set a bit of context, I'm currently a JC2 student studying for the A-levels, and to just take you guys a bit on a journey as to like how the education is like when it comes to students in Singapore studying for exams. So as you can see here on the screen, there are many different resources that students are able to use from. For example, for myself, I have lecture notes, lecture videos, and if that's not enough, we still have worksheets and online notes as well. So yes, indeed, students in Singapore have access to a wide range of resources. However, that brings about a huge problem, which is that when it comes to revision, I often find myself having that one specific question in mind that I need to find the answer to. Sometimes that question can be from that one particular subtopic which has that, that one phrase or that one keyword that I need to look up the definition for. So here's what happens when I need to revise for my exams. When I need to find that definition for that one specific question, I have to go and flip through all my entire lecture notes and try to find that one specific page number containing that one key phrase. And if it's not there, then I have to go on to my lecture videos, having to scrub through the entire video to find that one specific section. And if that's not enough, then I have to look at my worksheets. And so you can see that this brings about an issue, which is that the time I spend when it comes to revising for my lecture notes is actually used more in trying to find the definition itself rather than the actual revision. Yeah, next slide. So, and this isn't a problem that I face myself. It's actually a problem that many of my batchmates have encountered before. So, having done user research, we've identified this main issue when it comes to revision during examinations, which is that the time spent doing revision is spent more on having to look up that specific definition or having to find that knowledge rather than actually mastering and memorizing that content itself. So how have some students actually tried to mitigate this issue? They've turned to online resources such as Google searching or ChatGPT to find that one answer. So they have it like on screen with them as they are revising. And yes, actually, these online resources do help. ChatGPT does work. However, it does work a bit too well. Why do I say so? Because whenever the student searches for the answer, right, sometimes the online information that's out there actually gives knowledge that's contained outside of the syllabus. So yes, it's useful for lifelong learning, right? But when I'm staying up late at night at 11 p.m. trying to mark for my next exam that's the next day, right? I'm not trying to learn for knowledge that's outside of the syllabus. I'm trying to find out how exactly can I score for that one paper itself. And this is the same for students, right? When they go sit for the examinations, even though they have like knowledge that's outside, or they want to like express all their knowledge about whatever subject that they know, ultimately, if it's still not within the content syllabus itself, they will be marked wrong. And then finally, some students have also resorted to using Ctrl+F functions, on their online notes. However, it still faces the issue of having to look through all the different keywords that pop up to find that one specific definition. So yeah, ultimately, it still doesn't work. So yes, introducing Revel, which is our one solution to solve this issue. Revel, it's a smart search tool aimed to allow students to connect students with the knowledge necessary for them to revise for the examinations so that students can study smarter, not harder. Yeah, I'll now move on to showing you guys a bit of a live demo. We actually have that here. Wesley, can you? Yeah, switch over. So just to show you guys, this is something that's out there already. What we have, if you go to the videos, right? So let's say a student has like a specific question in mind. Let's say they want to search for enthalpy change. Enthalpy change is like a subject that's within the econ syllabus. So immediately it comes up here the specific videos that match the search query that it has. So if you click on the transcript button, it gives you the transcript function as well. But in addition to that, if you click on the timestamp of the video, it actually brings you to the specific video itself. I don't think Wesley is logged in yet. So, but basically what happens is that when you click on that, it brings you to the actual timestamp of the video where the answer is located in. If we then move on to the next tab, which is the notes, over here in the notes, we have a huge chunk of answer that will be already provided there. For example, definitions of enthalpy change is the first definition that pops up. And then finally, if you go on to the AI chat function, over here it gives you a very basic summary that the AI has come up with based on the search results of that has been derived. And then, if a student wants to ask a follow-up question, like say, give me a specific example of enthalpy change, yeah, the student can do so. So say, yeah, I want to find like an example what exactly is like an enthalpy change, and then it gives me yeah, you scroll down a bit. Here, the full case examples is right here. So yeah, back to the slides. Next slide. So as you can see, the product that we have launched, and in fact, we've launched it to our friends just today. So today was the first day where the entire student population within our school has access to this tool. And you can see that it's been created with intention. So for example, don't know whether any of those sharp eyes might have noticed, but we've placed the resource page specifically before the AI summary itself, because ultimately we want the focus of the students to be on the resources. So going back to your own lecture notes and videos before looking at the AI summary, so as to reduce the reliance on the AI summary itself. We also plan to integrate an automated pipeline for passing notes and videos. This is for the teachers in mind, right? Because we don't want the teachers to always have to upload the entire database into the into our database, so that, like for example, when they want to make a small tweak or change to their own lecture notes. These are some of the user metrics that we have. So as of now, we have 2 subjects, chemistry and econs, and we are intending on including physics and bio as well. As of end of 2024, we've had over 6,500 searches, and over 500 of our users actually currently active on this platform. One of the feedback that we've also received is that for students, it's a bit troublesome when they have to switch over from the current learning platform that they're using, Ivy, onto this search tool. And so we've made it much more accessible for them by integrating Revel into the learning platform that they have been using. So instead of having to switch over, now they can just head on to the drop-down menu and then access Revel from there. I'll now run through quickly a bit about how the search flow works. So as you can see, the student first, when it searches a phrase of word, it gets turned into an embedding before it's passed into the Pinecone database. From there, the Pinecone database executes a semantic search. And based on cosine similarity, it gives out the exact chunk output in terms of your notes and videos, and then before the AI goes on to summarize it. The building process itself consisted of redesigning the UI from just the basic HTML, CSS into the Next.js front end, and also we've had experiment with some prompts and to find one that will adequately summarize the return content. Finally, we've had the experience of gathering adequate user feedback and UI UX to better our model itself, because ultimately this will be a tool that we want students to actually use, and not just some product that we show out there and then just for like any old presentation. Some technical limitations we face is that when it comes to vector search, there is the fundamental challenge. For example, when in low dimensional spaces, right, the distance between points can actually vary quite significantly. But when it comes to higher dimensions, it's harder to distinguish between the relevant and irrelevant results. And so yeah, it basically just affects accuracy of our results.
All right, cool.
Yeah.
Sorry that I have to cut you guys off here. Okay.
Yeah, but this you can just check out here, and yeah, thank you so much.
Cool, thanks. Excited to come. Yep, thanks for that presentation. Next up we'll have Vivek from Cartograph.
What's this? Wait, test. Hi everyone, my name is Vivek. So today I'll be talking about documentation for AI coding agents. So before we start, just want to understand how many of you, consider yourselves to be like developers? Okay, how many of you use AI for developing? Vibe coding, right? So I'll be talking a bit about that. So before that, about me, I used to work at Handshakes, which is a local startup here in Singapore. Now I founded a company called Cartograph, which is working on creating documentation and understanding software engineering systems. So about Cartograph itself, just a quick introduction. You put in a GitHub repo, it parses it, generates documentation out of it, understands like the microservices and components of your system, creates architecture diagrams out of it, which is completely interactable. So you can kind of zoom in, understand the kind of dependencies that your system has, as well as generate some documentation for things like files, functions, and so on. So I won't be talking about that today actually. So what I'll be talking about is about AI models and how they really understand code and create code, because there's a problem that we faced. And one of the things that we noticed is that models work very well if you work with kind of the established popular libraries. So for example, things like Python, JavaScript, they work really well. But they're not as good for like less popular technology. And if you're in an enterprise system, it's impossible to work with your internal libraries because these models just don't know enough information about it. So why do we think this is important? Like being able to work on newer technology, I think is important because if not, our community, like tech community as a whole, will not have innovation, and new ideas basically cannot win out because just like language models are kind of focused on the older ideas, right? And if you think about it, like from an enterprise level, most of like world's code is kind of written in boring technology. So things like Java, things like even like in banks, you have Fortran and things like that. So what we have built is a way to provide language models with basically a hosted, clean markdown documentation of libraries and framework. So what we do is we go to a libraries documentation, process it, clean out the HTML into clean markdown, removing things like headers, sidebars, footers, and as well as kind of standardizing links so that AI agents can navigate correctly to get to the right page. How many of you know what's Model Context Protocol? Okay, quite a lot. It's quite popular, right? So we expose this as an MCP server to models to be able to access it. And for those that you don't know, it's just a standardized way to be able to link to your models, your services to like AI agents that you're controlling. Okay, now I'll try to do a demo. So what I have here is I have two folders set up. So I'm going to try to replicate like 11 Labs API, using AI to code out a 11 Labs API. And the only difference is on the right, I've set up Claude Code with my MCP. So the one on the right has access to documentation, the one on the left doesn't. So if I can, it's kind of difficult writing with one hand. Okay, so I kind of prepared, basically like help me write a Python script that converts a sample sentence and using the 11 Labs library. So I'll just run it on both sides. Okay, and the 11 Labs API is particularly interesting because I think somewhere a couple of months ago, they went through an API change and most of the, it's trying to install stuff. Just write the code. Okay. Okay, so both the one with the docs and the one on the left has run it. So if I try to run so you can see that it's basically getting some API error because it's basically trying to use the old API which doesn't exist anymore. And if I run the one on the right, okay, the one on the right doesn't work as well. But trust me, it worked when I was testing it. Okay. So I think, but we've been kind of using this internally quite as well. So one of the questions is like, why can't the agents find the information themselves? So what would generally be is like you use browser use, where basically the AI agent tries to navigate to the web page and get the information itself. But that is slow and expensive, at least for now. And it takes a lot of like redundant effort to go to a documentation site, index it, and be able to search for it. And while doing it, also there's a lot of like server issues. So for example, like misformatted links, server errors. These are all things that we kind of encountered. But I think the most important thing is like, I think HTML is not the right abstraction for documentation. And just take like this example. So the same page as HTML would be like 37,000 tokens for a model. Whereas if you convert it into Markdown, that's only 1,000 because you've removed so much of like the useless information, which if you kind of gave in the full HTML content, the model basically has to figure out what is important and also kind of uses up the context that is kind of can work with. The other option is basically looking through the code itself, but if you work in like JavaScript, you know like your node modules can be like 1 gigabyte worth of data that you need to basically like crawl through. So that's also not really sustainable. Yeah, so that's all I have. It's open source. You can try it out. If you're using any client that supports like model context protocol, now we have loaded a bunch of documentation that we personally use. Yeah, let us know what other documentation you want to be hosted. Okay, that's all I have. Thanks. Any questions? If not, then thank you. Oh yeah, sure. Sorry, no, now everything is automatic.
Then what differentiates that from, say, I use some libraries very often, and then I just have an MCP that just like have my memory.
Yep. That will basically be the same thing. Now I just provide a simple way to do that. All right, if not, then thanks.
discovering hidden patterns in customer
Let's see if this
conversations.
works. Huh. Let me see if I figure this out. Okay. Let me just one sec. This maybe? This? Oh, that shit. That's. Oh shit! I lost my screen. Wait, I kind of lost my window. Sorry, I'm facing technical challenges. Sorry, guys. Let me just try again. Display.
I guess people who deal with AI still face technical issues.
I think what I'm trying to do is just basically I have
Same
like
thing here and
I can have it like the same way, but it's
So I think maybe
arrange.
Oh, okay. No, sorry, done.
Yeah,
Maybe
and
advanced.
fans.
Oh.
Yeah, I'm genuinely confused.
OS.
Yeah, I'm like genuinely confused.
Maybe just search mirror display.
Mirror display. This one?
No.
Arrange multiple displays.
You can just drag.
Can I drag this? The problem is I don't know how to drag it back. Yeah.
Yeah.
Oh, well, that works. All right, guys. Sorry about that. Yeah, so today I'll be presenting on how to make sense of customer data at scale. This is primarily a problem you're going to face as you scale up your application. So I hope it makes sense, yeah. So my name is Ivan. I work as a research engineer at a small consulting firm called 567 Labs. We primarily work with companies to sort of figure out how to get and implement AI solutions. And so one of the main challenges you see from a lot of customers is that when you start talking and you start launching your app, it's great, people are using applications, but what do they use it for? Are they happy with how it's working? How do you know that, right? So after all, there's an overwhelming volume of unstructured conversations. At the same time, you can't exactly get your developer to look at every single conversation itself and figure out, like, is this good, is this bad? Were customers asking for pizza? Were customers ordering like 2 items, 1 item? Did my AI bot upsell them? That's not really gonna be helpful, right? And by the time you reviewed the 5th one, you forgot the 1st one or the 10th one, right? And so what this means is that a lot of hidden patterns and opportunities really remain undiscovered. And a key way of actually getting around this is using language models in a very smart way. So Kura is a small open source tool that I kind of built. It's really small, it's like 15 to 20 lines of code, so if you don't want to install a library, you can just copy all of them and re-implement it. So basically the idea is that it's really built with the same sort of ideas that Anthropic uses to analyze its own user conversations. And for them, it's a software called Clear, which is Claude Language Insights and Observations. And the basic idea is that instead of focusing on whether or not users are asking you questions like, what do I wear today is 25 degrees, I'm in Tokyo, right? You start to focus on the high-level patterns of what you care about. Users are asking for recommendations on what to wear. Users are asking about, recommendations or recipes, right? And the idea here is that by focusing on the high-level sort of user behavior patterns and things that you care about, you can start really trying to focus and think about what sort of features you should build, what changes you should make, and from there itself, try to figure out what to prioritize. And so I've tried to make the API really simple. So you just import from Kura. Then you can load in the conversation. There's a Hugging Face data set integration that I built. And so then it's just 2 lines of code to start clustering the conversations itself, and I built a small little cute UI. But basically, how does this approach work from a high level? You take a language model, right? You summarize every single bit of conversation according to what you care about, right? So for Anthropic's case, what they care about was, what are people using this specific conversation for? What is the high-level request in 1 or 2 sentences? For other sort of conversations, it might be that, hey, like for this user summary, what were the sort of items they were ordering? What were the sort of requests that they were making? From that itself, you get a bunch of individual summaries of topics. You can then cluster them using the embeddings. And so you get these individual initial clusters. Once you have these clusters itself, you can then cluster these clusters again. So you have meta clusters of clusters. And repeat this until you're happy. But what you tend to see is that if you explore this in the embedding space itself, where you see, oh, over here there's a cluster where people are asking about, like, how do I code in Python? How do I code in Rust? You can start to see that you see hierarchical groupings about this. When you care about certain topics where you say, okay, maybe my moderation classifier keeps flagging this, but my LM as a judge doesn't. Well, then you can look at it and find disagreements in that, and that's what a topic does. And so the idea here is that you find these topics, and you create, if you really care about these specific edge cases, capabilities you're trying to do, you explore this subset of conversations again. From this set of conversations itself, you develop classifiers, and you repeat this process. And the real goal is to identify what's the best thing for my company to do right now, what features should I develop, given the limited time that I have. So this is how you load different data sets. You have the Hugging Face data set. I provided like a whole bunch of different methods if you're loading a data set which doesn't have the same sort of fields. So we care about the chat ID to identify each chat. Messages function, how do you map it just basically to the OpenAI API spec. And I originally built it because I wanted to figure out how I was using Claude. I had 1,600 conversations with Claude, 2.4K today, I think. I don't think I was going to be able to look through it manually myself. And so we also sort of see like, that's like the third method you can use. So back to the original point of basically this idea of topic modeling, which is that you can start to identify general user trends. First one is feature prioritization. You can map user feedback with the query volume itself to drive development. For example, if you know that 10% of your queries are about emails, and users are never happy with that, and you have 75% of your queries that are just about, hey, I want to order something, or like, let's say something about something else, then maybe you should just tell, in order to raise the satisfaction, you should just say we don't do emails for now, right? Like certain queries can deprioritize, and if you see queries that are having very high satisfaction, right, or certain things that people are really actively using your bot for, you can invest more time in that. The other thing is sort of this idea of inventory and capability. Inventory is whether or not you have the data. If users ask you questions like, hey, when was this document last modified? But you never track that data at all, you're never going to be able to answer it. Similarly, 5 minutes. Similarly, when it comes to capability itself, if users ask you, hey, can you send an email for me, but your language bot just doesn't have the specific integration set, then you can't do that itself. And so the real idea behind really understanding these clusters is, where do I need to invest to increase the amount of data that I collect? Is there an additional index or additional index that I need to create? Or is there additional capability that my bot needs? Then the last thing is really just targeted improvement, right? So if you see there are specific things that you care about, for example, if you have a chatbot that takes orders, well, does your chatbot upsell well? What sort of upsells are you doing? Beverages? Are you doing like combo deals? Are you doing like size? Is it always saying, do you want a large with that? It's just 69 cents, or fries with that, right? You can start to train classifiers to extract these specific characteristics that you care about. So for example, in Anthropic itself, they recently launched Claude for Education, and there's a really interesting series of blogs that they wrote about it. The first thing they did is they analyzed about 1 million different interactions that all these like students have with Claude. Then they used Clio itself to identify these topics, and they realized that for a lot of these people, they weren't just asking questions. What they were trying to do is they were trying to understand a specific topic. They were using Claude as a way to guide them to explore like what needs to be learned for this specific topic itself. And you can think of it like a tutor, right? Hey, I'm interested in this. Oh, why don't you explore these things? Asking more questions, going back and forth. And then from there itself, like students were actually using Claude as a learning guide and not just a glorified search engine. So what does this mean? So you can kind of implement that with Kura. In this case, we have a single sort of classifier. So this is a Pydantic model that we define. Then from there on, you can just inherit from the summary model, which we use to summarize the conversations itself. And then from there, you summarize the conversation, and the rest of the code is, you can see it on the website. But back to the original Anthropic example. Sorry, I'm skipping a bit. I didn't plan for it to be this short. After they realized that a lot of people are using basically Claude as a way for question answer as a learning guide, you see the Claude for Education launch with this idea of like, it's a way for you to guide you to specific topics. They tried to make it very easy for students to be able to use Claude to explore these topics and learn about new things. And so you can see how a lot of the feature discovery, features that you should build, can be guided along with what sort of topics, what sort of relevance you're discovering. Same thing when it comes to inventory versus capability, right? When it comes to something like RAG you're using a lot, are people asking questions which you just don't have the data for, right? Your embedding models, if they're retrieving data itself, and you look at the user satisfaction, and you provide citations, are users never clicking on that data? Those are things that you can aggregate. Are users having conversations that are much longer, right? Is the average conversation turn back and forth increasing over time? Well, those are attributes you can track too, right? And same with generation capability, right? Do users copy the request that you have? Are users actually, going back and forth, modifying certain pieces of code? And so really it's about finding better ways to explore these rich sources of data that I think most companies are not, which I think could be quite interesting. For example, we had a company come to us and say, hey, we have a chatbot that's not answering questions about parking well. Like people just are never happy when we answer with chatbots. But we looked at the data and like 75% of queries, people literally call in to say, hey, can I get chicken rice? I just want chicken rice, dude, right? And out of that, the bot never upsold them on a drink. Like all the bot had to do was to say, would you like a drink with that? Would you consider some eggs? And they were made 30% more money, and it's just 3 lines, it's a 3-line change in your prompt. But if you don't analyze your data, you don't know that you can make small tweaks like this. And I think that really is the core, whether it's using Kura, whether it's using language models. A lot of these reasoning models are really quite incredible. They can craft great synthetic data examples. And I think by leveraging a lot of them, you can extract a lot more sort of value from your data. I was going to show a few more examples for Kura itself, but you can check it out, use Kura.xyz. If I think this is something you're exploring, I've talked to a lot of people trying to do conversation analysis and topic modeling. I'd love to talk about your specific use case and see like how that's being done. But other than that, happy to take any questions. Yeah.
Cool. If there are no questions, we'll move on to the next section. Thanks.
Was there one there?
Sorry. Was there a question?
Oh no, it's not a business. It's a fun project I did in my spare time. Unfortunately. I built it. I built an initial prototype in January. That's when Anthropic launched a paper called Clio. Then I had a bit more time recently, so I refactored it. And yeah, but we've used it a bunch in different projects, and you get some really interesting insights when you customize these summaries. When you look at when you modify a lot of these hyperparameters. So I think it's pretty fun in that sense. I think a lot of it is companies just come to us saying that we want to do this specific, we want to implement this idea, we have this problem, and the topic modeling, the analysis happens to be one of the methods that you apply. So it's just, you give me some data, you give me a problem, and we try to figure out how do you evaluate it, how do you get there, and for your engineering teams when they take over from us, what are the steps you need to figure out, what are the trade-offs you need to think about, yeah. So, yeah. Cool. Cool.
Cool. The next talk will be by Dr. Zhang from Weston Robotics, and it will be about from lab to startup addressing the challenges of practical robotics.
Okay, thank you.
If you don't want your audio to be recorded, you can take it off.
Okay, sure. Well, that's great.
Meta, Facebook, Yanliang is saying that we may need new paradigm in AI architecture to solve the challenges ahead of us. These are some of the people that has the most compute on Earth, saying that hey, we may have a problem. So we should better start listening to them. And because the reliability problem is extremely paramount, because like this is essentially what is holding back AI adoption. We have seen AI achieve amazing things, but the reality is that they have the random failure rate. It randomly falls into a ditch. It randomly clicks the wrong button, and then subsequently your boss is like, can I trust this in production? What if he accidentally delete my customer? And the thing is, existing solutions or right now the labs are actually heading into the direction of like, hey, we can just scale the transformer model. And frankly, this sounds like they just have a giant hammer and they just feel like this is the best solution because it does work. But it's like, how much capital do you need? So, a little bit of background. I'm Eugene. I'm an AI model creator. I co-lead the RWKV open source project as chairman and I'm founder CEO of Featherless. I'm born in Singapore, but now I'm like 80% of my time in SF. So a lot of things that I'm speaking is actually from my experience from starting from Singapore and then being exposed to SF and working in the open source space for over a decade. And this has brought me some rather interesting insights and experience. Like for example, as one of the few model creators on this side of the earth, I ended up, it brought me into places like the United Nations where I represented ASEAN as well at the WTO for AI and Asia because apparently there's only a few model creators here. And likewise, I've also been involved in Race SG. I see a few of you that may have been involved in that, where basically we discuss about the national AI strategy as well. So my first thing is there is another way. And that's what I'm essentially working on. So I work on the RWKV open source project, the first foundation model and architecture under the Linux Foundation. And then more importantly, that is non-transformer based. Because our argument is right now the scaling challenges and constraint is based on the architecture. Our existing models are already being in use in production. More specifically, we have over 1.5 billion of them installed on all your Windows laptops because Microsoft decided to shut it down all your laptops respectively. And this is used to do mundane translations, small tasks respectively of your CPU. It's typically a small model, around 1 billion scale. And the reason for that is our models scale linearly, and this graph actually applies for all post-transformer models. I don't have time to go to competitor analysis, but there's at least 5 post-transformer architectures, of which we are currently one of the leading ones. But the general thing is that as we scale by context length, so if you all use AI models as context lengths, we scale linearly. And well, you may not have heard of us for most parts, right? That's because until a few months ago, right, our largest models were around the 7 and 14B. But that just changed recently. Last month, we essentially dropped our 72B and 32B models, which is now today the largest non-transformer model that doesn't have the attention mechanism. And it's also the strongest post-transformer model today. This trait blows with existing transformer models of similar size, but what is more shocking is not the fact that it worked, which you'll hear more because it's crazy how we got this built, is that we didn't build this with a cluster. We don't have the money for this. We built it on a single node with 8 GPUs. And the thing is, what we realize is because intelligence is not in the attention mechanism. We argue it's actually in the matrix multiplication layer, or more specifically, the deep network layer. So what we actually did, right, is we took an existing QAN model, we literally delete the attention layer, freeze the FFN layer, add an RWKV layer, train it and unfreeze the model and train it even further. A process that somehow worked. And you think about it, we literally deleted 1/3 of the model, reinitialized it and did some training on it, and it worked without the attention mechanism, proving that the statement attention is all you need is actually false. Because when you step back, right, like I say, what you really needed for the model is actually matrix multiplication. I would even argue this method, right, that we did for training this model would work even with our competing architectures, state space, XLSTM, yada yada. Because the core intelligence, right, from what we realize, is actually in the feed-forward network or matrix multiplication. And this is important because architecture changes have dramatic results. When we mean compute differences, right, on the same GPU, we can do over 100 times simultaneous requests compared to existing transformer models. And it can perform at similar performance. This is the kind of fundamental shift that we actually want to be researching as we scale. And the other shocking thing is that when we proposed this, I expected an across-the-board degradation in performance, but instead we got improvements in some metrics. So, like I said, it proves that attention is really not all you need. And the thing is that there's so much potential in architectural changes because there is improvements to be made. So the quick one is, yes, R1 conversion is on the way, yes, there is a paper, and if you are counting, 72B means we are only 2 steps away from GPT-4 because once we hit R1, then we need to do reasoning, and we are basically caught up. So, but that's not the only thing I feel, because here's my hot take. Actually, we do not need a bigger model. Like, people are training trillion parameter models, and I think that's dumb, because right now the best model, be it DeepSeek, which is 100 billion active parents, can do impossible feats like orbital physics from Earth to Mars in under 5 minutes. Can any of us do that? Yeah, I don't think so. Yet, right, cannot even be a chatbot to reliably do customer support. The thing is, models are extremely capable, but they are unreliable. Capable means you can do 1 in X time, like 10% chance. Reliable, can you do something 99.999% or not? And that is essentially the problem. And we see this across our platform, where we run thousands of models. Thousands of models, like thousands of fine-tune, which I can go through another time. But the thing is, more excitingly, right, when we look at production enterprise workload, right, we always think bigger models is better, right? But look at the left half, it's freaking Mistral Nemo 12B, a mini model. Why? Because these companies, they fine-tune to solve one particular task and they just whack on it. And that is the name of the game, reliability over capability. So what we really want, right, is not AI to cure cancer with 1 trillion parameters. It's really for it to do the boring things in life, like sort out emails, make sure that my email from my ex goes into the trash can, and label things properly. And it's like, or sometimes just to be a friend. Because we just want the AI to automate things so that we can enjoy the little things in life. So originally, our platform is like about serving the best models, right? We have started making the shift, right, into basically building personalized AGI. Because the other thing that I'm saying is, Quirky represents our latest model, right? It represents the largest model of a memory module. And why this is a big thing, right? A memory module is what is essential for learning from mistakes. So we all heard of long context. Long context is like putting a book in front of me. Right, it's like taking a page out of it and tearing it apart and then feeding me bits of it. And despite having all of this in front of me, I still burn the freaking fried rice. Why? Because I lack the experience that is required from actually the cooking experience, the experience from mistakes. And that is the challenge we face in reliability. How many of us have put the problem? When you see A, do not say B, and the model proceeds to say B. Like, that's the challenge that we face. We need the models to actually learn from those experiences. And that is essentially what we are tackling. And I'm not saying that we have it solved. Look, I don't even think we are at critical level yet. We are slightly better in prompting and fine-tuning. But what I'm saying is that we are a team that for the past 2 years has been making big steps in changes every 6 months because we've been experimenting at architecture where everyone's like, oh, let's not touch it, let's just stick to transformer. And the big breakthrough for us for Quirky is what used to take months and millions to train now costs us weeks and thousands to train. So yeah, that's what we are building towards. And the last thing that I would like to say, right, one more thing, Singaporeans, AI is your freaking moment. Why I say that? Singaporeans outnumber nearly every Asian country in SF, in the AI labs. You cannot find an AI lab without a Singaporean. In fact, there's a mini game in SF called Spot the Singaporean. The record is 3 words. I don't even finish my sentence. They ask, are you Singaporean? and the thing is that the AI digital revolution is about individuals with the right idea who can change the world. All you need is a laptop and internet. So dream big. And I'm not saying this because the government sometimes talks to me, right? It's in fact, if anything, I think they don't dream big enough. Because what you see us achieve, right? We achieve 100 of the resource of other team. So don't let anyone tell you can't do what you dream in AI. Do it.
I think we're happy to move on to the next speaker, John. John and team, who will be presenting about AgentJo plays Pokemon.
Hi everyone. Anyone here has seen Clock Plays Pokemon? Raise your hand. Okay, so basically I've watched the stream for more than 2 weeks, and after that I realized that you will never complete the game Pokemon. Okay, so what's missing here? All right, we heard the previous presenters talk about LMs are not the only thing that you need. Robots not able to calibrate to new environments. That's now our previous speaker also talked about maybe we need memory. We need to train the memory to tune the model. Why? Because actually LMs are very good with their training data. Once you generalize beyond that training data, even if you fine-tune it, it might not work. Right? So what do we need to do? Okay, we need to imbue it with different forms of learning, different forms of memory. Here, this AgentJo Plays Pokemon is an experiment to play a game world, in this case Pokemon, that uses image. So we use a multimodal large language model, but that's not enough. Because we still need to do a lot more things, like reasoning over various domains. In fact, I think reasoning is not even the only thing that we need, because a lot of things that go on in the brain don't use any reasoning at all. When you recognize a face, you say thinking is a face? Not really, right? It's a vision model. So a lot of things are actually algorithm-based, a lot of things are already encoded for, and you need to integrate them with the large language model. So LM is only a very, very small part of it. So over here you can see this is the game. It takes in the picture, it interprets with pixels, it comes out the current state, which is like what's in the thing, reflects on whether or not the previous action works or not. So over here it realized that the action right did not work, so it learns on the fly. Okay, I'm not interested in systems that work at the very start. I'm interested in systems that can learn and adapt to its environment. And that's why our team here is trying to tackle the AgentJo Plays Pokemon. AgentJo is a framework that I've created to interface with LMs to do agentic pipelines. So over here, our team here, Dylan, he helped to do the API integration. He will be talking more about it. And Nicholas Tan over here will talk about memory stitching of visual memories. And finally, Nicholas Chen will talk more about future work and how we can use memory to improve the adaptability and learnability of these agents. So you can see the agent has really moved down. You can see he can also do his own goal planning, explore the starting location, try to find the character in palette town and so on. So I'm going to just switch to the other screen to just show you a bit of AgentJo. So AgentJo, you can just go and see this is the GitHub. The Pokemon repo is all over there. You can see the projects here. And under Pokemon, all our code is open source because I want this to be an open source project, because I believe advancements happen when we do things together. So over here, you can see the code itself. I made the AgentJo multimodal. You just do double angle brackets. It will just reference this file and then interpret that as an image in the LM. Here we use Gemini Flash 2.5. Then we can also do chain of thought by just doing a list of outputs. And this is how we do it. We do action, prediction, compare the prediction with the action with the next state. If it doesn't work, we reflect on why it doesn't work. And then we continue to do it until we solve the game. So without further ado, let me move on to Dylan to talk about the API.
All right, thank you, Chong. So let me just switch to the slides real quick.
So basically, once we get enough funding for this to run this 24/7, it will be live streamed, like what you saw earlier. So we are still looking for API key sponsors because it's quite expensive to use it. So if you are interested to support this project, do let us know. All right, Dylan, you can use the computer.
Okay, so hi everyone. So I'm Dylan, and let's just go through like the overall sort of theme of the project. So PokeAgent, catching them all with vision language models. So the main goal of what we are trying to do is to make a autonomous agentic system for Pokemon raid gameplay. So here's the overall architecture of how we are doing the overall, like the streaming, sort of the technical part of the gameplay itself. So the main part of the code is all done using Python. This is so that it's easier, faster to integrate. It uses a PyBoy and open source Game Boy emulator, and using Flask, we are able to serve web pages that you saw in the demo just now, as well as the API endpoints for interacting with the app. So the benefit of using this approach is that anyone over the internet can actually access the agent itself and be able to provide actions, read images using their notebook over here. And there's also a web UI that shows the memory thoughts as well as the agent thoughts, as you saw in the demo just now. So part of the way that we're doing interfacing and sharing is, so this is the general logic we're going with here. The game state is provided by Pyroy, and the API is served by Flask, and then the agent logic that runs locally on a notebook can be used to interact with the system and be able to provide actions and also take in image information as well. So a part of the extensibility of the project that we're looking forward to do is to really be able to, in the future, allow chat viewers to influence the agents as well. To do so, we are using secure remote access using Tailscale to expose the API endpoints to certain secured users. And the idea is that in the future, users, chat viewers on the live stream itself will be able to influence the agent and provide human feedback to really make it better. As for how we are going to achieve this, we have a few ideas, but maybe you can ask us later in the Q&A. But I'll be passing my time on over to Nicholas. We'll talk about the map information.
Yeah, so as John shared, AgentJo is now multimodal. So what the vision language model is multimodal, but we can pass in images and text to the model. So what you can imagine is that the model will see image 2, and you also have a bunch of text history. But as the model progresses, right, we don't want to pass in the entire history of images, right? You imagine if you give it 100 images, it's going to get very, very slow. So what we did was a simple non-AI method. This is just pixel-based stitching. So for each image, I just compared it with the previous maps, and I found out where the image is in the map. And then the next step would just be to stitch the image into the previous map, and then we get a bigger map. Yeah. So we basically did this for each room. Basically, if there's no previous matching map, we just make a new map. And this has been going on, and so we just pass this map together with the current image so that the model knows where it is in the grand scheme of things. Yeah. So if you think about how humans think, they don't actually have a pixel level map in their head. So what we realize is that in the future, this is still quite kind of computationally expensive, right? We don't actually need every single pixel. So we've been looking at other projects, and what some of them have been doing is things like object detection. So this will let us get the semantic meaning of individual pixels, and we can just save that instead. Or they made mini-maps, which is a low fidelity representation. So this is just very simple, right? But it's good enough for the model to understand where it is and where it needs to go. Yeah. So this is it for the imaging part for now, and I'll pass it on to Nicholas for the future works.
So I'll just briefly touch on future work and what challenges this environment could actually pose for AI. So one very simple example, I mean all these are based off existing works, they run on Pokemon environment and they start to struggle. So one clear-cut example is, okay, so sometimes the perception of LLMs is not very strong. It mistakes some things, for example, it mistakes this patch for Pokemon Center. But the problem is, even after it tries to interact and it doesn't get the expected response, it still holds on to that belief. And we are wondering if are there any belief updating mechanisms to then, like a scientist mode to help correct for this behavior? And some challenges for human-like AI, because intelligence requires a whole bunch of components, and LLMs do not display all of them. So we hope that these challenges could sort of review such things should we have very good AI for. The first example is humans have this intuitive psychology. We natively perceive the world in terms of entities, humans, other humans, or other objects, their goals, and whether they are friend or foe. This is very intuitive. Whereas in LLMs, sometimes it just confuses entities. It doesn't really try to make the connection of who is supposed to do what, and even confuses this nurse joy for the machine sometimes. The next thing is humans do not just predict the next token of action. build internal models of the world, and so can we get AI to sort of figure out the vector or catching system, or even play one variant and then be proficient in another. And lastly, like adaptability and efficiency. So the only thing that beats Red right now is deep RL, but you can't tell it to do side quests. And like, can you learn by watching others as well? That's a lot of information.
So that's all for this. This is a work in progress. We hope to show you good examples of how we can use multimodal memory, multiple abstraction spaces to learn, to retrieve and adapt. So feel free to see the code. On the left one is our GitHub code at AgentJo for the Pokemon code. The second one is if you want to run this environment yourself, we open source the Poke Agent code, so you can run the Pokemon environment on your laptop. This third one is the YouTube stream. Once we do it live, we will let you all know. Then the last one is my Discord, where I basically want to build fast and adaptable agents. I'm not sure if you all have heard my presentation before on AgentJo, or like the previous name was TaskGen. So basically, I want to build fast learning and adaptable agents that can adapt to changing environments, something quite different from what LLMs can do now. And I believe the key to do that is memory. And also another thing is about emotions and how to use that to learn better. So that for another time, all right? So we'll talk about that another time. Thanks so much for my team, and thanks for listening.
Cool, thanks John and team. I think we will take questions after.
All right.
Cool, next we would have Kanika. So the next section will be about AI in practice, and we'll have 3 speakers.
Hey everyone. So quite a big shift from the talks that we've seen until now. I'm focusing more on healthcare and even a more complex domain of healthcare, which is mental health care. So I'm from MindPeers, and we basically help with what we call value-based mental health care. So which basically means that after analyzing data and doing a bit of personification, we are helping to give insights to end users, that is patients, to insurers for better policy underwriting, as well as to healthcare partners. We've been in the market for about 6 years now. This is the year that we've entered Singapore. So we've been working out of US, India, Latin America, and Indonesia. And the reason for that was one, cultural nuancing, and second, because of large populations who could be catered around the mental health problems. Now, when we talk about AI in mental health care, it's very important to understand what are the problems that are there, what are the problems that exist. And there are 3 problems that we are solving for with the AI agents that we have built. The very first one is that when it comes to scaling of a therapy model in mental health care, it's very difficult. You go to a therapist, and a therapist can do limited number of therapies every month. It's already a problem in the US, where a patient is able to see their therapist probably after 60 days or 90 days because they don't get an appointment. And in a case like that, how do you go about things when your therapist is not available? Whether it is resources, whether it is self-care, all of those things, how do you handle that? The second is that research shows that mental health professionals are spending 60 to 70% of their time doing admin work. When we say admin, operational work, we are referring to things like sorting resources, bringing people to book sessions, taking care of the debrief notes, and all of those things. The second thing is because we work directly with B2B. So we have a B2B model and a B2B2B model, which means that our major customers are insurance companies and employers themselves. The engagement on mental health platforms is always very low. And the reason is not because people are not going through things, it's just the stigma and a lot of other things which are not personalized for them, because of which the engagement is low. And last of all, measuring something in mental health is very, very difficult. So as a result, what we basically did was, the first 3 years of the company, we had a lot of unstructured data that was collected confidentially across all of these things that we are seeing. So we provide assessments, our therapists give diagnosis, there are psych notes, there are customer messages that came on simple chatbots regarding their concerns, regarding their symptoms, regarding what they're feeling, what they were diagnosed of, what kind of treatments helped them, and so forth and so on. And just 2 years ago, we also implemented what you call biomarkers. So what it basically means is, if some of you are from healthcare, you would know that physical health and mental health are correlated. Today, if your vitamin D and B12 are very low, you're 30% more prone to depression. Or, let's say if you're going through thyroid or diabetes, your symptoms of anxiety disorders are even more. So the idea was to also implement an API which automatically syncs the behavioral and the biomarker aspects of the user and able to deduce their mental health symptoms and give them treatment according to that. Now, as a result of all of this, currently we have produced 3 AI agents, which are namely helping in detection. So under 2 minutes today, a person gets an idea of what kind of issue or concern they might be going through. And it's a big one, because the awareness of what you're going through is very low. Either someone will go and Google it, or they're just going to self-diagnose that, hey, I was feeling this, so I have OCD or I have anxiety. So what our system over here does is, you go in and you just have to express whatever you're feeling for the last 2 weeks, and you sync up your biomarker lab report. I'll show you shortly. We're using a very simple thing for that. We're using GPT and Claude for that, where you upload your lab report. It understands all the primary parameters that affect your mental health, and under 2 minutes, it gives you a report of what you might be going through and what is the next steps that you need to be able to either prevent it or treat it, right? Similarly, we have created this engagement agent. Now what it does is, depending on what the user is taking therapy for, without the intervention of the therapist, we are able to give personalized resources continuously to the user. And we do a lot of clinical researches, and we have found out that when the AI agent sends them the resources, they're 70% more prone to complete it, because it's happening very discreetly. The other bit, I won't spend a lot of time on it because my time is going away, but we also created a tool. This is a personalized tool called CogniArt, which stands for Cognitive Plus Art. So what it does is, people who are not able to verbalize what they are going through, we have done prompt engineering on this, and they basically draw it out, and the drawing is analyzed, and personality analysis, symptom analysis, all of those things are done from this. The last of all, this is an outcome agent. So you can see here, the report is uploaded, and then post that, all the matching of the different parameters are done, and we basically make use of time series data, etc. So what is happening is, in parallel, if you're taking care of your mental health through CogniArt, through therapy, through different tools, and it just doesn't have to be on MindPeers, it can be anywhere else as well. We are studying that alongside, we are studying your physical parameters, your behavioral parameters, and then we are giving outcomes from that. What you see in red are some of the journals, literatures, and papers that we have published with NHS in UK, as well as American Association Psychology in the US. So this is just basically the architecture of how the time series data, structured objects from, we also understand the financial well-being of the person, the therapy data, all of these things are processed, recommendations, detection, etc. is made, and on the basis of how the user is reacting to it, the progress that they're showing, it's again put into the feedback loop again. Very small things. We started off this about 1.5, 2 years ago, even before we came up with the agents, where, for example, for the biomarkers API, this was the starting of us using artificial intelligence in the mental health care. A lot of you would be already aware of Streamlit. So we basically used that to do the text summary of all the medical data that was produced, and we used that to give the reports to the therapist so that they don't have to do the admin work, as well as a summarized report to the end user as well. And the other thing that we had started off with, now we're using Claude, but earlier we were using GPT, where the lab report data would be read through. It would validate where the report is coming from. If there are any inconsistencies, it would throw an error. And then after that, it would return the enum where we would read blood sugar, diabetes, thyroid, and stuff like that. And then according to that, we would let them know that if it's affecting their mental health or not. I think that's for my time. We do keep taking a lot of feedback, and now currently in Singapore, not just that we're hiring, but we're also doing a lot of research projects where we are working with ML engineers, etc., to build on the accuracies of the mental health care aspects that we have over here. And if also there are any questions, feedback, you can post it here, and I'll be happy to discuss it further.
Thank you so much. Cool. Next we'll have Parag from SSD.
Hello everyone, I'm Kura. I'm an architect, a building architect, and a sustainability consultant, and I'm the founder of Sustain. So today I'm going to talk about how we're creating smarter workflows for green buildings. So why green buildings, right? Today we're hearing a lot of buzzwords around sustainable, ecological buildings. In fact, the building we're in right now is one of the foremost green buildings of Singapore. Why? So buildings are causing a heavy effect on our environment. 39% of world's carbon emissions are from buildings. 34% of world's energy consumption is from buildings. And in a recent survey done by the Building and Construction Authority of Singapore, green buildings are a key to fighting climate change. 85% people agree to that. Not only that, it comes with a few fringe benefits like health and well-being in spaces, low utility bills, even comfortable indoor temperatures like you must be experiencing right now. So you may ask me, what is the recipe for green buildings? I know that a lot of you might not be from this domain here, so I'll just give you a quick overview. It all starts with a developer hiring an architect to design something that they want to build. The architect then assembles his team. You may have heard of engineers, quantity surveyor, but the sustainability consultant is a very recent addition to building projects. The developer also hires a main contractor who brings in subcontractors to basically construct the building. And sustainability consultant starts liaising with these certification bodies who will actually certify that this building is a green building. Then all the information from this design team is disseminated to the contractor to construct the building. And you may notice that a lot of the information that goes from the sustainability consultant consists of information from other consultants as well. It's a lot of overlapping information, and that is what is eventually used to construct the thing. So you may notice that this is a collaborative and integrated process with a lot of exchange and back and forth of ideas and documents. These documents are essentially spreadsheets, tender specifications which may be 200-300 page long, and even calculations, which creates bottlenecks in our processes. So most of the compliance checks are done manually in this industry, which is the reason for the bottlenecks. It may be by consultants, architects, or even certification bodies. And as it may be obvious, these bottlenecks basically lead to unproductive use of time, inaccurate submissions, delayed project deadlines, even limited knowledge of green building codes because of the frequent updating of these codes. This is where Sustain steps in. So Sustain Copilot is an AI-powered assistant for green building teams. It helps to automate your compliance checks, generate reports, automate your follow-ups to your project teams, and it also comes with around-the-clock expert assistance through a green building chatbot. And on top of that, we provide a dedicated project repository and workspace for a collaborative action on the project. So our product overview highlights how we basically take all the building info, which may include data sheets, tender specs, design drawings, sustainable design features, and generate AI-powered compliance reports for the users, actionable task lists with reminders and follow-ups, annotated documents which are ready for submission. So this is a quick demo of our tool. We support multiple certifications on our platform, and we have made the process of selecting a particular credit easy for the user. Here we have uploaded 2 documents and we'll run a compliance check for this. So you may notice that the tool follows a step-by-step approach using agentic AI. It first extracts all the credit criteria, and then it analyzes it against the user document that we uploaded, and then it generates a compliance report along with the task list. So the compliance report is divided into 2 parts. One is the written report. Other is an annotated document. So this was an 18-page document. Now I don't have to go through all the 18 pages. I just have to skim through these 3 pages where the relevant information has been highlighted for me. On the left-hand side, which is the written report, so mainly the analysis section is what tells you which information from this document is relevant for you. And the carefully extracted information is then neatly put into points, compared against the credit criteria, and the relationships are then clear to the user there. Furthermore, it produces an editable task list where you can select the stakeholders you want to send the reminders to, and through our third-party integrations, we support follow-ups through calendar reminders, which can directly go to the calendar or your project team's calendar. And it also helps to generate drafts for emails. So you don't have to sit and write extensive Excel sheets, remember which document I have to ask from which stakeholder. So you can just generate the drafts and then write in the email of the recipient and just send it out at the end of the day. So you may notice that the compliance assistant is one concise tool, but the chatbot is a more versatile tool. So what we have designed the chatbot is for doing a detailed analysis of your compliance reports, to produce design statements which are ready for submission, and also to even ask basic questions on your day-to-day operations on general green building scopes. So here I've produced a design statement, and it neatly organizes all the data it extracted from previous documents and the credit criteria, and everything is neatly put into one summary. So this can directly be copied and put into my final report for submission. So the chatbot not only answers to text-based prompts, we can also do a preliminary analysis of architectural drawings, where we can analyze which credits the drawing is capable for, how many points we can score on this particular drawing, where all I can find the loopholes, where all I can improve my design and enhance my design to close any gaps that there may be. So all in all, we help stakeholders in the building industry to maintain their sustainability metric throughout the stages of a project. Whereas in a conventional project, you may notice that the sustainability metric goes down, especially during a detailed design stage or construction stage, where there is a lack of resources in doing compliance checks effectively and lack of checking whether the product is compliant for this green building standard or not. So yeah, if you are from this industry or know someone who would like to streamline your workflows, do reach us. And here are the QR codes for contacting us and for the slide deck. Thank you.
Yes. Cool, thanks Pulak. Next we'll have Wei Shui from Intent Bridges to give us a talk on who owns the data your AI gives.
Thank you. Cool, so last one. So it's only me and you are from going home, right? So let's try to make it like worth your 5 to 10 minutes last, right? So the title today is about who actually owns the data, right? So everyone's building your own AI apps here. Show of hands. So yes, you will think, of course, I own it, right? I'm building it. So why still put it? Because actually there's other people thinking it differently, right? So we're here in Intent Bridges trying to solve like, what is the gap between the AI companies and who's the, the answer owners. So actually, who contributed, right? So it's the AI apps that builds it. You guys build it. The LLM providers, and most importantly also, the content owners. So now you see in the ecosystem, now, actually AI apps, you guys are probably charging subscription fees and other ways. You're getting a pie of the, piece of the pie. LLM providers, they are charging you APIs. But what about the content owners, right? So this is where the tension comes in, right? Because the content owners, they're not getting any value yet in the ecosystem. So everyone's pushing for the next frontier, but actually content owners who generate the resource, the source knowledge, is actually being left out. So there's basically a lot of tensions in the ecosystem. So today, I hope you can walk away with a few things like, where is the tension coming from, right? What is the tension? And what do we see the future looks like to solve that tension? So basically, of course, it's more complex, but I kind of categorize into two type of tensions now, is pre-trained and then rate, right? So pre-trained, to give you an idea, like, for example, a lot of people, they train there are a lot of models, they're trained their kind of a language model based on Wikipedia, which is Wikimedia here. So you see that they're actually crawling the box. So actually Wikipedia actually are kind of raising the flag saying that, hey, our infra is not kind of like designed to be kind of handled with all these kind of bots coming to our websites. So they're undergoing a lot of threat. So to a certain extent that probably they only budgeted for a certain amount of budget, but now it's way over than that for their infrastructures. So what's happening next, right? So basically what happens is now Kaggle is actually part of the Google, so they're actually saying that, hey, Kaggle, you take part of my content, you deal with all these people, all these bots coming to our websites. You kind of take that out of my plate. Don't come to my website, right? And on the other hand is that you will probably see like Google now, they have used a lot of Reddit's answers. So now they think that Reddit answers probably pretty gold. So and Google and OpenAI now is kind of like wanted to do a licensing deal with these content owners, right? So this is pre-trained, is part of the tension. What about the other side, right? So what about the array tension? So what happened is that, so the internet has been kind of like operated on a consensus. Like I post my stuff on the internet, Google index it, but redirect back to the website, I get traffic. So what happens now is, now AI bots just give you the answers. So there's already a lot of stats saying that it's 95% of the traffic drop. If you cite it, does anyone really click on the citations? AI answer gives. We see there's a good users that are deep learners. But for me, I used to click on it. Now I just trust it. So like so good. Why should I click? So you see now traffic dropped 95%. No click. So what happens now? Because these content owners are founded by clicks on the internet, which is advertising, right? Which we all hate. So we know there's a bunch of advertising. But actually, it kind of like founded the internet, founded the open web, founded the RAG kind of tension here. So, right, so one of the key point I want to take away today is one is the New York Times lawsuit. Why I say so? Because this is a flagship media. So now the lawsuit started in 2023. So now it's 2025, and the judge is asking the lawsuit to move forward. So what does it mean for AI apps and builders here? Because if this lawsuit passes, and I think it might pass, so they will ask all the AI companies to start giving back money to the New York Times. So what it means is that now on your balance sheet, there's an extra data cost line. So this one is very important because I think it's going to happen in the next 1 to 2 years. So now no one's talking about the data cost, acquisition cost yet, because LLMs, those guys are absorbing it. But in the future, once this lawsuit passes, the cost will likely to transfer back to all the people building on top of that. So this is one of the key takeaways I think you guys can walk away with. So you can see that there's a lot of people suing a lot of people. If you track more, probably there's more people suing more people. So that is the challenge, right? So what is the way forward? So I think, or we think, in the future, it's gonna be like Netflix. What does it mean? So Netflix, you have licensing deals to the contents, to the hit movies, right? Spotify, you license the music, Taylor Swift, on the Spotify platform. So you go to Spotify, you go to Netflix. You don't go to individual, kind of like the content creators. So the AI apps is going to be very similar to that in a future economic model. So it will be a lot more like, okay, so OpenAI is licensing with Reddit, so they are licensing with Reddit, so they have the best answers. So you go to OpenAI, ChatGPT more. So what does it mean also for the AI apps, right? So if let's say in the future is that who has the best, if coming from this analogy, who has the best kind of like hit movies or hit songs will win, meaning that who controls or who licenses the best data sources might also win the game based on the domain you're building, right? So whoever has the most dominant, trustworthy data source will be this case. So this is the second takeaway. I believe in the future, it's going to be more about a Netflix, Spotify licensing model between AI apps and content owners. So this one, not happening yet. So there's still time, but I think it's going to happen in the next 2 to 3, 4 years. So so walk away, so two things, right? First is that the tension is happening. What we believe is that there's going to be a lot of license deal coming out. So for AI apps, AI owners, I think start thinking about if these kind of costs coming up, can I absorb it? And then can I have a different moat here? It's like data is the moat, the content is the moat to give you the answers. For example, there's still some, I would say data or content sources that OpenAI is not trained on. So if you have that kind of like a different kind of like deal, that also give you a different advantage to your apps. Yes, that's pretty much it. Hopefully that makes sense for the last of the chat. Here's my LinkedIn. Please reach out if you have any questions. Thank you so much for your time. Thank you.
Thank you, Steve. And finally, we'll hear from Daniel, the founder of Menlo.
Okay, we were supposed to do a presentation, I think, just very quickly, but I think for those of you guys who are new to AI showcases and all that. I think we help to put this on. I think really want to thank the library again and make sure that we really good. Okay, yeah, thank you so much. So usually, so after each AI showcase, we actually usually go downstairs for drinks. But today, I think we'll be going over to the bar over there, and we have to get out of the library on time. So I think let's get out of here so the librarian doesn't get in trouble. And then a bunch of us will be going for drinks, I think, across the street. Okay, so you'll be sort of seeing us sort of diffusion drift our way to the bar. So just come along and I think that's where it's. It's a great job, Daniel. So Daniel's actually our intern. He's heading out to university this year. So good job. Thanks, and hope you guys enjoy your time. And please leave.
Yeah. Nice to meet you.
It's final thing for you, right? Just take this. This high speed.
Oh, I got my table. I found my table. Yo,
Yeah. It was tragic.